software-defined radio. So this is the kind of guy who gets to perfectly exchange with Sébastien Bourdeau-Duc, who presented the FPGA challenge, and you get threads that go longer and longer and longer in the mailing list, with fewer and fewer and fewer people understanding. And they're going things like resonator for multi-gigahertz communication and capacity to reuse. Maybe if I say something like a lawnmower part, I'm exaggerating, but not much. Like, okay, we deal with bits, they deal with electrons.
Ouais. Il y a un collable. Il est vraiment, il est bien ce gars-là.
Ouais, il est hyper bien. Moi je suis fan.
Ouais. Allez, hop, j'enregistre. Ah oui.
Est-ce que tu montes une bonne là-dessus là, c'était plus
Bah ouais. Ouais, carrément. Si on...
To try to use software-defined radio like USRP. For example, people during the last TCC have shown GSM hacks, beginning to sneeze even the spectrum of GSM. In David Maynor, tried to establish, to launch some research on spectrum analysis using OSRP, and we were wondering if USRP was the best solution to make radio eavesdropping. That's why USRP is important or not. And what is USRP? What is the software-defined radio? And why? What should we use those kind of receivers? At the beginning of the radio, the technology was stuck with two major problems. First, the bandwidth and the linearity of the component. And that's for this reason why, to receive, for example, a frequency of 10 megs, we had to mix this frequency of 10 megs with a local oscillator located, where is my mouse? Located here. This is the local oscillator. This is a mixer. And the subtraction of the local of the receiving frequency and the local oscillator was giving an intermediate frequency VIF. For a very simple reason, that it was easier to amplify a signal at this frequency than directly at the antenna. The second problem was to decode the modulation scheme, AM, FM, single sideband, PCM, and so on, was made with a pure hardware-based demodulator at this stage. So we had two main drawbacks with classical radio receiver, that was the mixer in the well and the demodulator. This scheme has been invented by Eugène Ducretet, founder of a company called TopSum CSF, later, and has been used since 1910 approximately. At the beginning of the 90s, new technological developments right, that means PLL. Everybody knows what PLL is. DDSs, that means direct synthesizer, direct frequency synthesizers. FPGA, I think that's give you a quite good idea. And for the low end, the Taylor mixer and the sound blaster card. Why? Because of that. Because of this. With the DPS, it was at last possible to mix directly a frequency very close to the frequency you were trying to receive, and going directly to, well, the amplification and degradation stage. That means if you want to receive, for example, 200 megahertz frequency, you just have to mix this incoming frequency with no L at approximately 199 megs, and you have a 1 meg final signal. This is a direct conversion receiver. This is the simplest receiver you can build. Why using this kind of technology? Because now a DBS is able to cover from now low-end DBS is able to cover from 0 to approximately 1 gig. The Super 8 structure, the first one, was able to do exactly the same thing, but by step. It was impossible to make a continuous sweep from 0 to 1 gig, from 0 Hz to 1 gigahertz. And then the steps were approximately in traditional receiver of 500 kilohertz. That means if you want to receive a TV information with 500 kilohertz,